Unit 2, Lesson 2, here we go. Our lesson objectives are to find the sum of finite arithmetic and geometric sequences, recognize when the infinite sum of a geometric sequence exists and calculate the sum, and use series to model real-life word problems. We'll do that a little bit at a time, but really we have a lesson later in this unit that we focus on that more than we do right now in this lesson. All right, so let's talk about what is a series. So last time in lesson 1, we talked about a sequence, and a sequence is a list of numbers that has a rule or a pattern to it. So what is a series? Well, a series is taking those quantities arranged in a specific order according to its rule and adding them up to get a total, right? So a series is when you get a sum, when you add the terms together. So we use that capital S because that means sum of some particular amount of terms, and then you start with the first term, add the second term, and you keep going until you get to whatever the 10th term is. So if I said I want you to take the sum of the first 75 terms, we would have the sum with the sub 75, and then of course our last term in that series would be the 75th term. Okay, so this first series that we're going to talk about is the arithmetic series. So what is an arithmetic series? Well, it's when you take the sum of an arithmetic sequence. So the list of numbers in an arithmetic sequence, if we were to add those numbers together, then it would be an arithmetic series. So that means there should be a common difference between each term in that series. And there is. It's plus 1. So it says, what is the sum of all of the numbers between 1 and 100? Well, you could either sit there on your calculator and add up 1 to 100, or if we said try to do it as quickly as you could, what is something you might think of to do? Some of you might say, hey, if I add the first term and the last term, I would get a sum of 101. If I add the second term and the next to last term, 2 plus 99, I would also get a sum of 101. If I add 3 and 98, I'm going to get a sum of 101. If I add 4 and 97, I get 101. And you could keep pairing the first and last and move until you get to the middle two numbers. Keep pairing them until you get 101 multiple times. Now, if we are listing 100 numbers and we're pairing each of the 100 numbers off with another number to create 101, then how many pairs do we actually have? We only have 50. So you could quickly do the math, 50 times 101, instead of sitting there on your calculator and punching in all those numbers. So instead, we would say the sum of the first 100 terms is 5,050. Now, if you look at what we just did, that helps you pretty much understand this formula right here, right? So the formula for the sum of n terms, so the sum of n terms, so this indicates how many terms are in that series that we're going to find the sum of. Capital S says we're going to take the sum of all those terms. We would take the number of terms that we have in the series, divide it by 2, just like we did here. There were 100 terms in the series, we divided it by 2. Then we take the first term and the last term, just like we did here, to add them together so that we can get that total. Now, this is not only the only formula that we're going to give you on the formula sheet. We're also going to give you the second one. That's the sum of the first n terms is n divided by 2. But now we have 2a sub 1 plus the common difference times n minus 1. Okay, why? How did we get this? Well, hopefully you're remembering our last lesson from lesson 1, which talked about the arithmetic sequence. So if we know that the nth term is equal to a sub 1 plus d times n minus 1, we're going to substitute this in for the nth term, right? So I'm going to take this value right here, this entire thing right here, substitute in for a sub n. So that's what I did here, and then I have 2 a sub 1s and the rest of the plus the common difference times n minus 1. So we will give you both of those formulas on the formula sheet, so you can use either one, and really you're going to determine which one to use based on what information was given to you. If we give you the first and the last term, then you're going to probably use this first equation. If we only give you the first term and the common difference, then you're probably going to use the second equation. So let's move on. So example 1. It says find the sum of the first 150 terms in this series, 6 plus 12 plus 18 plus 24 plus 30 plus ... So we want to find the sum of the first 150 terms. So the sum of the first 150 terms. We could either use this formula, or we could use the second formula, which is 2a sub 1 plus the common difference times n minus 1. Do we have the nth term? Do we have the last term, a sub 150? No, we do not. So we're probably not going to use this first formula. You could, but you'd have to find a sub 150 first and then plug it in. Instead, to save some time, we can use the second formula and we can say n is 150. So I'm going to do 150 divided by 2, twice the first term is 6, plus my common difference times 150 minus 1. So I haven't calculated my common difference yet, so let's check it out. I just assumed this was arithmetic because I just introduced the arithmetic sum of the arithmetic series to you, that formula, and so let's check it out. Do we add by the same number to get from term to term? Yes, we do. To get from 6 to 12, you add 6. 12 to 18, you add 6. So yes, it is arithmetic with a common difference of 6. So now you punch that into your calculator. Go ahead and try it. Punch it into your calculator. You should get the sum of the first 150 terms is equal to 67,950. So that is the answer you should have gotten. You can use this same strategy and try number 2 on your own and see how you do. So when you did this on your own, did you get 2,500,000 or 2.5 million? Hopefully. If not, you should go back and check, right? Reread the question. It says you're increasing your sales by 20,000 each year. You want to know how much you'd have after 10 years. If your initial year was 160,000, that's your first term, increased by 20 to get 180, increased by 20 to get 200. So I use that formula, plug it in, check your math if you didn't get that answer, because you should have gotten it. All right, moving on. So for example 3, it says calculate each sum. Well, if you have an arithmetic series and it's increasing and increasing and increasing, it goes on infinitely. That's what those 3 dots mean. Can you actually find a sum? So the sum to infinity? No, it's just going to continue to go to infinity. You can't find an actual numerical value because it just keeps getting bigger and bigger and bigger and bigger. Same if it continues to negative, you subtract and subtract and subtract, or add a negative number. Again, your sum to infinity, as you subtract and subtract and subtract, it's just going to go to negative infinity. So you really don't have any sums to calculate there. So that's it for the arithmetic series. Now how about our geometric series? So your geometric series, we are going to have a formula for the finite geometric series, and that is here. So it is the sum. A geometric series is when you're adding up all of the terms in a geometric sequence. So we would take the sum of the n terms. We only need a sub 1, and we need our common ratio. So it's a sub 1 times 1 minus the common ratio to the nth power. Notice the only thing being taken to the nth power is the ratio, not the 1 over here, not the entire parentheses, just the r to the nth power. Right? So that's going to come into play. Some of you will forget that, but you need to be careful. And I'll talk about a strategy to kind of remind you of that when we do example 4. So example 4 has a sequence. It says find the sum of the first 8 terms of this sequence. So the first term is 4, the second term is 40 over 3, the third term is 400 over 9. So it's clear that we're not adding by the same number over and over, so then we must assume that it's geometric. If it's geometric, we find the common ratio by taking a sub 2 divided by a sub 1. Or we take a sub 3 divided by a sub 2. Or you can just kind of figure it out. 4 times what number will give you 40 over 3, right? So hopefully you're saying to yourself, well, I need to get 4 over 1 to become 40 over 3, so 4 times 10 is 40, 1 times 3 is 3, so my common ratio is 10 thirds. Or I can say 40 over 3 divided by 4 over 1, which is the same as 40 over 3 times 1/4. That's 40/12. Or you can cancel, which again gives us 10/3. So my common ratio is 10/3. So now I'm going to find the sum of the first 8 terms. So the sum of the first 8 terms, oops, I don't know why I put an infinity symbol. The sum of the first 8 terms equals the first term, which is 4, times 1 minus the common ratio to the nth power. So what I strongly encourage you to do every single time is to put your common ratio in these parentheses, even if it's a positive value, because sometimes your common ratio is going to be negative. So go ahead and get yourself into the habit of putting that common ratio in parentheses now, so you won't make a mistake, a calculation error when it becomes a negative. Right? So always just write it on your paper, put your common ratio in parentheses, just in case it's negative, so you recognize that you're subtracting a negative. But here, again, I just want you to recall, or want you to recognize that only the ratio is being taken to the power of 8. Right? Only the 10/3 is being taken to the power of 8. So you need to practice, plug it into your calculator, make sure you get the same answer as me. So plug it in. So you should get 26,126.707. So double check. But that is what you should get. If you didn't, you're doing something wrong with your calculator, so you need to try it again. Example 5. So it says, consider the sequence 128, negative 64, 32, negative 16, all the way till we get to 1 over 512. Yours might just say, I think, 128 minus 64 plus 32 minus 16 plus, and then dot, 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 and then 1 over 512. So it might have said, consider the series. I'm not sure. So determine the number of terms. So part A says, determine the number of terms in this sequence. So what does the number of terms mean? That means we're trying to find n. What does n represent? So 1 over 512 is a sub what, right? So what is n? So first we need to figure out, is this series or sequence arithmetic or geometric? Well, it's going from 128 to 64 to 32 to 16. You might want to just pause for a second and say, okay, what if I disregard the negative sign and I just make them all positive? Now it's very clear that it's dividing by 2, dividing by 2, dividing by 2, or we would say multiplying by 1/2. But actually, specifically, it's not multiplying by 1/2, it's actually multiplying by negative 1/2. So in actuality, my common ratio is negative, right? It's negative 1/2. But we can disregard the negative for determining which term 1 over 512 is. So we just figured out that it's a geometric sequence, so I need to use that formula that we learned in lesson 1. This is the formula to find what term we have in a geometric sequence. We substitute in a sub n with 1 over 512. We substitute in 128 for a sub 1. Instead of putting in our negative ratio, we're just going to leave it as a positive, right? Just pretend, disregard the alternating signs, right, as I had before, and just make them all positives so we can figure out which term it is. But in the end, we know that our common ratio is actually negative. So this is a non-calculator question. So what am I going to do? Well, hopefully you recognize that all of these numbers are base 2s, right? They're 2 to some power. So let's recall our 2s. So 2 to the power of 1 is 2. 2 to the power of 2 is 4. 3 is 8. 16, 32. I'm just doubling them all. 128, 256. So 256 and then 512. So 2 to the first power, second power, 2 to the third power, fourth power, fifth power, sixth power, seventh power, eighth power, ninth power. So this equals 2 to the ninth power. If my 512 is in the denominator, then I need to move the 2, so it's 1 over 2 to the 9th power. 128 we see here, this is 2 to the 8th power, 2 to the 7th power. So 128 is 2 to the 7th power. And then 1/2, I can rewrite that as 2 to the negative 1 power, and then take that to the power of n minus 1. Oops, so I didn't do that all in one step. So here, notice that I took my 2, I put it in the numerator by taking it to the negative power, so I need to do the same thing with my 2 to the 9th power. So I'm going to make this 2 to the negative 9th equals 2 to the 7th, and then I'm going to do what to these exponents? Right, so what do I do when I take 2 to the negative 1 to the n minus 1 power? So hopefully you were saying to yourself, you would multiply those exponents. Sorry, got messed up there. You would multiply those exponents to get a negative 1 times n and negative 1 times 1, so it's to the power of negative n plus 1. So I have 2 to the negative 9th. What do I do to these exponents now? And hopefully you are saying you add them. So I would get 2 to the power of negative n plus 8. And because both of these have a base of 2, I'm going to say negative 9 equals negative n plus 8. Therefore, n equals 17. So all of that for part A. Determine the number of terms in the sequence. The number of terms in the sequence, there are 17 terms in this sequence. For part B, we're actually going to calculate the sum. Well, we've said it's a geometric sequence, and now we're going to add them up. So we need to take the sum of a geometric series, and we just said there are 17 terms, so we're taking the sum of the first 17 terms of this geometric sequence. So our formula was such that we put a sub 1 is 128. We do 1 minus the common ratio. The common ratio is now a negative 1/2. So we take that negative 1/2 to the 17th power, and then we divide by 1 minus negative 1/2 again. Right, so my common ratio is negative, so you must be very careful. Put that into your calculator with the parentheses around the negative 1/2, and you should get your calculation to work out just fine. If you don't put the parentheses around it, then you're going to get an incorrect answer. A negative value raised to an odd exponent is going to make that overall number be negative, and then 1 minus the negative is going to change it to positive. So try this on your calculator. Pause, don't look at my answer. Maybe pause your video and then try it. So you should have gotten 85.334 because it's 3339844, etc. So you had to round up. So you should have rounded to 3 decimal places. It would have been 85.334. Now for example 6. It says, suppose you have a set of nesting boxes in the shape of cubes. That's what this diagram is, your nesting boxes. The largest has dimensions of 40 by 40 by 40. The second box has dimensions of 32 by 32 by 32. The third box is 25.6, etc., and so on. How many boxes would you need to stack to reach the ceiling that is 3 meters high? Okay, so like unit test 1, some of you are making the mistake and you're not switching your units. So 3 meters high is actually 300 centimeters. So you need to make sure that you change that to 300 centimeters. Okay, now we have to decide, is this sequence arithmetic or geometric? Well, you can clearly see we're not adding by the same number, so I'm going to assume that it's geometric, which means it has a common ratio. To get my common ratio, I take the second term and divide it by the first term. So they're both divisible by 8, so I get 4/5, or some of you might prefer to write 0.8. So regardless, it's geometric with a common ratio of 0.8 and a first term of 40. Now I'm trying to figure out how many boxes I would need in order to get a height of 300 centimeters. So what do I need to calculate? Well, hopefully you're saying to yourself, this is the sum of all of those adding up, right? Stacked on top of each other. I'm going to add this height plus this height plus this height until I get to 300. So I have to take 300 centimeters and set that equal to the formula, the sum formula for a geometric series. So that's my first term times 1 minus the common ratio to the nth power, because we don't know, we're trying to figure out what the nth term is, and then I divide that by 1 minus 0.8 again. So 1 minus 0.8 is 0.2, so I can cross multiply over here. So 300 times 0.2 is 60, so I get 60 equals 40 times 1 minus 0.8 to the nth power. I can divide each side by 40. So 60 divided by 40, that's 3/2, or 1.5. That equals 1 minus 0.8 to the nth power. So now I'm going to subtract 1 from both sides, right? So this cancels. So I see on my right-hand side I have negative 0.8 to the nth power, and this is 1.5. 1.5 minus 1 is just 1/2. So let's think about this. If I have this negative sign here, I could divide by -1, divide by -1. So now I have 0.8 to the n power has to equal -1/2. Can I take a positive base and raise it to an exponent and get a negative number? Hopefully there's alarm bells going off in your head and you're like, wait a minute, that is not possible, and you would be correct. We cannot take a positive number, raise it to an exponent, and somehow get a negative result. It's not possible. So what does that mean about my infinite amount of boxes? If I can keep going and going and going and going, because I'm taking 80% of the next height, it means that those boxes are getting so teeny tiny that eventually they're so small they're never going to reach 300 centimeters. How high are they actually going to reach? Well, if I did the sum to infinity, right, I'm going to take my first term, which is 40. I'm going to use this same formula up here. I'm going to do 1 minus 0.8. Oh, that looks funny. Oh, well, 0.8 to the nth power. And I'm going to divide it by 1 minus 0.8. So this 0.8 to the nth power, well, let's say this is to the 1,000,000th power, the 100,000th power, or the 10,000th power. Put that into your calculator. If you do 0.8, that's a fraction that's less than 1. If I take a numerical value that's less than 1 and I square it, or I cube it, or I take it to the 4th power or the 5th power, those numbers, because it's less than 1, they get smaller and smaller and smaller. So 4/5 to the first power is 4/5. 4/5 squared is 16 over 25. That's smaller than 0.8. 4/5 cubed is 64 over 125. Now we're approaching 0.5. It's going to continue to get smaller and smaller until it gets closer and closer to 0. So this fraction, 0.8 to the nth power, is approaching 0. So I would just get 40 divided by 0.2, which ends up being 200 centimeters. So in actuality, these boxes that we continue to stack on top of one another are really going to approach the value of 200 centimeters. They're not going to get anywhere near 3 meters or 300 centimeters tall. So this was not a possible task to accomplish. Now that goes to our last formula. Our last formula is about an infinite geometric series. So we can calculate an infinite geometric series if the sequence is decreasing and if the common ratio is caught between -1 and 1. And why can we do that? Well, when your common ratio is less than 1, right, then we just showed that it's going to approach 0. So this 1 minus, that becomes 1 minus 0. R to the nth power becomes 0, so we just get a sub 1 times 1 divided by 1 minus r. So the infinite geometric sequence formula is probably the easiest one you're going to have. It's just a sub 1 divided by 1 minus r. What's tricky is people remembering that you can only actually get an answer if your r is caught between -1 and 1. And another way we can write that is just to say the absolute value of r is less than 1. So even though you get an r that's greater than 1, you might get a numerical value and you might be able to calculate the infinite series, but your answer is actually going to be wrong. It's not going to make sense. So you have to pause and ask yourself, wait a minute, is this a scenario where I can actually find a sum? Is my common ratio caught between -1 and 1? So you can try example 7, example 8 on your own. I'm sure you're going to be able to get through them. Let's do example 7 really quickly together, then maybe you can try example 8 on your own. So this is geometric. We're going to take second term divided by first term to get the common ratio, or third term divided by first term to get the common ratio. Yes, they're both 0.2, so my common ratio is 0.2. If I'm calculating the sum, it has ends in a ... which means it's an infinite series. So I'm going to use this formula up here. The sum to infinity equals the first term divided by 1 minus the common ratio. So I get 5 divided by 4/5. 5 divided by 4/5 is the same as, we multiply, flip that fraction upside down. So my answer is just 25/4. You might want to write 6 1/4, or you might want to write 6.25. We don't care. All of those are the same answer. All right, try number 8 here on your own. Perhaps you can see here your common ratio. Just take the second term divided by the first term. So your common ratio is √3. Don't let that sway you. So it says, given this sequence, determine which term will first exceed 4,800. So again, which term? That's asking me to calculate for n. So which term will first exceed 4,800? So that's just going back to your basic a sub n equals a sub 1 times r to the n minus 1 power. So have a little go at this. You're going to need your calculator. This is a calculator question. So stop, try it, and then come back if you're not sure. Okay, so what you should have done for this one is you should have plugged in your 4,800. It equals your first term, which is 4, times your common ratio, which we said was √3, and then we're taking that to the x minus 1 power. I changed n to x because I need to use my calculator in order to solve this. My left-hand side, I'm going to put in to y sub 1. My right-hand side, I'm going to put into y sub 2. You might want to make those numbers smaller, right? You could also divide each side by 4, and 4,800 divided by 4 is 1,200. 4 divided by 4 cancels out. So you could also put these numerical values into y sub 1 and y sub 2. It just means your window is going to be a little smaller, but it really doesn't matter which one you use. So what are you looking for here? You're looking for your point of intersection, right? So when will 4,800 intersect with 4 times √3 to the x minus 1 power? Or when will 1,200 intersect with √3 times x to the minus 1 power? So we have one graph coming up like this. That's √3, to x minus 1 power. And then we have another graph coming across at 1,200. So this was your point. You should have gotten around 13.907 and 1,200. And that, of course, is not actually the answer. The answer says determine which term will first exceed 4,800. So it means exceed, it needs to be bigger than. And we can't have a 13.907 term. So which term would make my sum first, or my term first exceed 4,800? Not the sum, excuse me. Just when will which term will actually be bigger than 4,800? Well, the 13th term would not be bigger than 4,800. So you have to round up because we want it to exceed. So you would have the 14th term, or a sub 14. And finally, our last example here is something you've done in Algebra 2 Trig if you're from our system. So you would have to use this formula for an annuity, right? This is the money that you're going to make in the end. This is the principal amount that you invest initially. This is the interest rate you have. This is how many times it's compounded, and then the number of times it's compounded per how many years you invest it. Don't forget that your interest rate needs to be converted to a decimal. So it says, Mr. Sean has decided to donate money to several charities when he saves $50,000. If he invests $8,000 into an account that earns 7.5% compounded monthly, how much will he have in 20 years? So I would pause and just use this formula and use your calculator and then check your answer with mine here momentarily. So you are investing initially $8,000, you have a 7.5% interest rate, you're compounding it monthly, which is 12 times per year. 12 times per year over the course of 20 years, you should end up with $35,686.54. I had to round up according to my calculation. So you should have had $35,686.54. How long will it be before he donates the $50,000? So you need to graph that in your graphing calculator. So you would have y sub 1 equals 50,000. That means we're trying to find t, right? We don't know t. So you're going to set that equal to 8,000 times 1 plus 0.075 divided by 12 to the 12t, or x, power. So when you set 50,000 equal to this, you're going to get a numerical value. I forget what that numerical value is. I want to say it's somewhere around 25 point something. But go ahead and plug it into your calculator and then pause and then come back and I'll tell you what the answer is. All right, so you should have gotten around 24.511 years. He would have the $50,000, and that's when he'd be able to donate. You don't have to worry about telling me if that's, a certain month, a certain day of a certain month. No, we don't care that. Just round to your 3 decimal places like you would. And that is the final answer. Thanks. Hopefully it went well, and we'll hear you next lesson. Bye.